Hello. Okay. In today's video, we're going to talk about how to balance redox reactions, and on the way, we'll kind of learn about oxidation numbers as well. Okay. So there's two ways you can balance redox reactions, or two places, I should say. One of them would be in an acidic solution, and the other would be in a basic solution. So let's take this equation, for example, UO2 plus aqueous plus Cr2O7 2 minus, also aqueous, becomes, let's write like this, becomes UO2 plus 2. Okay, this is a U, I do want to specify that. Plus C3 3 plus aqueous. Okay, so first things first, you guys understand we have to, like, the very first step we have to do is make something called a half reaction. Okay, what's a half reaction? A half reaction basically describes which of these substances is getting oxidized and which of them is getting reduced, okay? Because this is a redox reaction, so you would write down, okay, oxidation, and then you would write the fucking reaction, and then you would write reduction, and then you write that reaction, and then you would have two half reactions, okay? So now, let's kind of figure out what is getting oxidized. Well, in order to understand what's getting oxidized and what's getting reduced, you have to remember the definition of oxidation and reduction. I like to remember oil rig, okay, where OIL stands for oxidation is losing, and rig stands for reduction is gaining. Okay, losing or gaining what? Well, obviously we're talking about electrons. So oxidation, you're losing an electron, right? Thus your charge becomes more positive. Reduction, you're gaining an electron, so your charge becomes more negative. I like to associate reduction, right, with the reduction of charge. So if you were, for example, O2 2 minus, the more electrons you gain, the charge becomes more and more reduced. Okay, so that's how I like to remember it. All right, so let's remember oil rig on the side here for ourselves. And now we have to find out which of these two substances is oxidized and which one is reduced. Okay, so how do we do that? Well, in order to understand this, you have to understand a little bit about oxidation numbers that can help you. So first of all, this entire molecule has a charge of 2 plus. So I will write down 2, okay, equals to 2, which is the charged molecule. Oxygen, usually in many scenarios, oxygen, okay, instead, let me rephrase this. Oxygen, in many scenarios, has an oxidation number of -2, except for when we're talking about peroxides and superoxides, okay? So when we're talking about peroxides, so when we're talking about peroxides, oxygen's oxidation number is -1, okay? Now, it's important to understand that the oxidation number is not actually it's not a real number, okay? It's like a hypothetical kind of charge, if you will, like it's not real, okay? So, yeah. Anyways, back to it. So, oxygen is -2. What is, I believe this is called iridium. Well, we don't know. I don't know what this is called. Okay. Let's try to find it. Okay, I can't find it on the periodic table, to be honest with you, but I don't, like, listen, we don't know what the oxidation number of this, but we do know the oxidation number of this oxygen, and we know the charge of the entire molecule, so we can write an equation for it as such and figure it out. So we can do x minus 2 equals to 2, right? Correct? This is what we can do. And with that being said, actually not like this. It would be x plus minus 2, okay? Because the combination of these two charges added together should give us this 2 plus. So let's kind of move things over and isolate x. This would become 2 minus minus 2, which gives me x as 4, and we can test this hypothesis. We can plug 4 into this equation. So if I do 4 plus minus 2, will that give me 2? Let's see. And yes, that is true. It does give me positive 2. So we can conclude that the charge of this guy, or the oxidation number, I should be careful, is plus 4, and this one is minus 2. Another thing you would really be fair to notice is that a charge is written with the plus on this side, and oxidation number is written with the plus on this side, okay? All right, now we want to figure out who gets reduced and oxidized, right? So it's super easy. You just kind of, and you know, I'm doing it super slow for you guys to understand, but you come over here, you take a look at this molecule now, and now you figure out its charge. Okay, let's do it a bit faster. We know the whole molecule has a charge of plus 2. We know that oxygen is minus 2, but there's 2 oxygens here. So I'll do minus 2 times 2 plus x. Okay, great. So minus 2 times 2 is minus 4. We'll move it over. Okay, and we'll say it's 2 minus 4 equals to x. Right? 2 minus 4 is the same as saying 2 plus 4, which is 6. So x equals 6. So this guy is now plus 6, and this guy is minus 2, but remember, it's times 2. Okay? So we can check for that and say 6 plus minus 4 gets me positive 2. That is correct. Now, we can now easily figure out who got oxidized. So this molecule went from having a plus 4 to plus 6. What does that mean? That means that it increased in positivity. That means that it got oxidized. It lost electrons, and electrons are negative charges. So if you lose negative charges, you become more positive. So this molecule become oxidized. Okay, now we can write our oxidation half reaction. Remember, oxidation, by the way, occurs at the anode. I always like to kind of write this, and then I'll write cathode reduction. Okay, so now let's write our oxidation reaction. We know that UO2 plus gets oxidized, as in it loses electrons, and turns into UO2 2 plus. Okay, the real question is how many electrons were actually exchanged here? Well, it went from a plus 4 to a plus 6. So if I can do simple math and say 6 minus 4, that equals to 2. So there were 2 electrons, okay, released here. Okay, plus 2 electrons. That's my oxidation reaction, half reaction. Now I got to write my reduction half reaction. So this one's pretty easy. I don't actually have to think about it. I know that this is Cr2, 7, 2 minus. Okay, this becomes UO2, oh, sorry, Cr, I'll write it like this, Cr3 plus. Now, what is the oxidation number of these? And you're like, hey, well, why do I have to figure out the oxidation number for these? I already know that this is the oxidation, this is the reduction reaction. That's a good point, but we need to know how many electrons were kind of exchanged here, correct? So we will figure out that Cr2O7, 2 minus, has what oxidation number? And then we will figure out what is the oxidation number of this. Now, I'll tell you something very interesting. This ions, monoatomic ions, their charge is the exact same as their oxidation number, right? So their oxidation number for this guy would be 3 plus. Okay, super simple. Anyways, now let's take a look at the oxidation number of this. Again, the whole molecule has a charge of -2, and oxygen we know is -2, but there's 7 oxygen molecules. And now we want to figure out this chromium, correct? So we will write, since there's 2, we will write 2x plus -2, 7 equals -2. Okay, -2 times 7 is the same as -14. Okay, so I will write 2x equals to -2 minus -14. All right, the reason I have a minus here is because the previous one was obviously addition, right? It's basic math. So we will do -2 minus 14. And that will give me 12 2x, but we're not done yet. So we will do x is equal to 12 over 2, which is 6, okay? And we could easily check for this by plugging 6 into this equation. So if I do 2 times 6 plus -2 times 7, the answer should be -2, which it is. So we conclude that Cr2 plus has a charge of, Cr2 had a charge of 6 plus, okay, or plus 6 I should write. And don't make a mistake here. This is not for 2 chromiums. This is for a singular chromium, okay? So this one Cr has plus 6, but Cr2 has plus 12, okay? But that doesn't really matter to us because we know that this is plus 6 and we know that this is plus 3. What is happening to the number? It is getting reduced, right? It's reducing in charge. So it's going from plus 6 to plus 3. It's reducing, so that means the molecule is being reduced. Okay, now if I can do basic math, I will know that there are 3 electrons being exchanged here. So I will write plus 6 here. And thus I will write 3. Let's get rid of this, okay. Plus 3 electrons, okay? Why am I doing plus 3? Because reduction is gaining electrons. So I am adding on this side of the reaction. So now you can see that I took this general kind of reaction and I turned it into an oxidation half reaction and a reduction half reaction, okay? So that was my first step. We're not even done balancing yet, okay? This was my first step. Now you want to balance the elements that are beside, you want to balance elements beside oxygen and hydrogen, okay? So what do I mean by this? So now just take a look at this equation, okay? I have one of this U and one of this, and I have 2 oxygen on this side and 1 oxygen here. Well, remember, these are all in aqueous solution. Where do I get oxygen from in an aqueous solution? It has to be from water, okay? So you know what I can do? To this oxidation reaction, okay, this half reaction right here, I can actually add something. I can say that in order to balance this equation, I can add a water molecule. Boom. Perfect. I can add a water molecule. And this water molecule, it'll actually produce, right? It'll equalize the number of oxygens that we have. And you might be thinking, well, okay, Kian, now there's actually a 2 hydrogens on this side. And I'll say, yes, you're correct. There is 2 hydrogens on this side, but guess what? I will just add 2 protons here. Because once I strip away the oxygen, I will just have free-floating protons now, okay? Because remember, this oxygen will combine with this oxygen to make this, all right? And now I can say this equation's balanced. This half reaction, this oxidation half reaction is balanced. Now I will do the exact same, right, with this guy. So I actually erased the oxygen there, but I have 7 oxygens here. So how many water molecules do I need on this side, guys? What do you think? I need 7 water molecules. So I will add 7 water molecules. And you might be saying, well, hold on a minute. Now you have 7 times 2, that's 14 hydrogens. That doesn't sound right. And, you know, quite frankly, it is correct. So I will add 14 protons on this side. I shouldn't say hydrogens, they're protons. Okay, now, I've balanced the oxygen, I've balanced the hydrogens, okay? Now, the other thing you have to do is balance the charge, okay? What does that mean? I have to balance the charge. What are you talking about? You have to balance the charge with the electrons, okay? So, I actually have 2 electrons here, and I have 3 electrons here, but guess what? I will find the lowest common multiple, okay? And I will multiply them, okay? To make the electron number match. Right? Right? So, oh, actually, I'm sorry about that. We forgot to do one thing. We said that this is 2Cr, right? We said one of them is +6, but we don't have one of them. We have 2 of them, so it's +12. And over here, we only have a singular ion of this, so we actually should add a 2. And there you go. That fixes the problem now. Okay? So let's balance the charge with the number of electrons. Okay? What do I mean by this? So on this side, what is the charges that I have? What is the total amount of charge I have? Huh? The total charge currently is what? There's 14 H pluses, okay? So that means the entire charge on this side is 14 plus. And then, forget this. Then I have a 2 minus, okay? So I will actually subtract by 2. And that makes 12 plus. So the charge on this side is 12 plus, excluding the electrons for now, okay? Don't count the electrons for now. The charge on this side is what? Well, it's 3 plus, but we have 2, so it's +6. Okay, what is the charge here? Well, the charge here is 2 plus, okay, and another 2 plus, so that's 4. But remember, so hold on, we have +4 here. What is the charge here? The charge here is +2. Okay? So, total charge on this side is +2. Total charge on this side is +4. Total charge on this side is 12. Total charge on this side is 6. We want to balance the charges with electron number. Okay? So how do I make this side go from +12 to +6 with respect towards, of course, the reduction half reaction, right? Because you know, the third step is to balance using electrons. Balance the charges using electrons. I can't add an electron here because it's a reduction half reaction. The electron must be here. So what do? Well, instead of adding 3 electrons, I will just add, what will I add? I will add 6 electrons, because 6 minus 12 is 6. Okay? That's what I will do. Okay? What about this side? How do I make this go from +4 to +2? Well, I will just add 2 electrons. But what do you know? We already have 2 electrons here. Okay? All right. So that's that. Now, you gotta remember. The next step is this. So what have the steps been so far? 1, split into half reaction. 2, was balance oxygens with water, and 3, balance hydrogens with H plus ions, okay? 4 was balance other elements, okay, such as, you know, this chromium here, this U here, okay? The 5th one was balance the total charges, okay, with electrons, okay, with electrons. Number 6, this next step that we're going to do is match the number of electrons, correct? Match the number of electrons. So, what do I mean here? I mean that, look, this one's 2 electrons, this one's 6 electrons, okay? So I will simply just multiply this side by 3 to match the number of electrons, okay? But remember, when I multiply this by 3, the whole thing gets multiplied. So what do I mean by this? So that means this becomes 3, this becomes 3, this has a 3, this becomes 6, and this becomes 6, okay? So those are some of the steps so far, okay? Those are the 6 steps. And then of course step 7 would be to combine these half reactions after we've done all that and add them all up. And that's where you finish with the acidic stuff, okay? All right. So let's continue this. So we will, let's switch to black here and multiply by, we can get rid of these now. Multiply this side by 3. So this becomes 3 this, 3 this, 3 this, 6 of this, and 6 of this. We will add these 2 reactions together now. And I will have 3UO2 plus Cr2O7, 2 minus, plus 3, well, you know, I'll do this. 3 water plus Cr2O7, 2 minus. I will already just cancel out the 6 electrons. Okay, and you know, I can cancel because they're on opposite sides, okay? Plus 14 protons. Next, I will have 3UO2, 2 plus 6 protons, plus 2 Cr3 pluses, and 7 waters. Okay, am I done here? No. I have to cancel out what I don't need. I will cancel out 3 waters here, and 3 waters on this side, leaving me with 4 waters. Okay. I will cancel out 6 protons here, and 6 protons from this side. 14 minus 6 leaves me with 8 protons. And I don't believe there's anything else for me to cancel out, so my final balanced equation is 3U2 plus Cr2O7, 2 minus, plus 8H plus, 3UO2, 2 plus 2 Cr3 plus 4 water. Okay? Very simple. Right? That is my balanced reaction. Well, at least I believe it is. Right, it is perfectly balanced. Okay, but you see, this wasn't so bad, and you can do this quite fast if you just practice. Okay. So, that was how to balance in an acidic reaction. Now we're going to do an example of balancing an equation in a basic solution, and you will find that it is extremely extremely similar to do. Extremely similar to do. So let's balance this equation. Sulfur solid plus oxygen chloride. Okay, it's a polyatomic ion. Aqueous. Turns into this guy. Okay. Plus Cl minus. Okay. So, balance this in a basic solution. Now, this one is actually quite easier to do. Again, you have to split into two half reactions, so I will already write down my anode oxidation, cathode reduction. Okay. I will then assign kind of, oxidation numbers. So another kind of thing about oxidation numbers that you have to know, we said there's a couple of laws. So, for example, oxygen will always be -2 except for peroxides and superoxides. Another thing is hydrogen will usually be +1 except in metal hydrides, like sodium hydride, where sodium will actually have the positive charge and H would actually have a -1 charge, okay? So just be on the watch out for this. The other thing is pretty much any group of halogen will, you know what, actually I won't say that. I won't say that. That's fine. I won't say it. Another thing I will say is solids, like monoatomic solids like this, they don't have a charge. It's just 0. Or oxidation number, not charge. It's just 0. Okay? So, I am just going to go ahead and predict that this goes from a 0 charge to some charge, which must mean that this is getting oxidized. I'm just going to predict that this is getting oxidized for my own reasons. But let's kind of do it. So we know this guy has a 0. We know that this guy, 2 minus equals to -2, 3 plus x. Okay, so we can rewrite this as -2 minus 6. And this will give me 4 as x. So this means that this is actually +4. So, going from 0 all the way to +4, you have lost a lot of electrons. So, like I said, I was correct in the prediction. This is becoming oxidized. Okay? And that's 4 electrons. So we can write this. Sulfur immediately turns to SO3 2 minus plus 4 electrons. Right? And we'll write down the electron number. The other one, of course, is going to be the reduction reaction of OCl minus plus however many electrons turns into Cl minus. So the oxidation number on this is -1. The oxidation number here, though, again, oxygen will be -2. Okay. It's actually quite easy to do here. So it's -2 plus x equals to -1, and you will just do -1, wait. Yeah, so you will do x equals to -1. You'll bring this over to this side. This becomes a positive now, -1 plus 2, where x is just 1. So I have -2 plus 1, and that gets me -1. That's correct. Okay? And so now you can see that this goes from a +1 to a -1. Of course, it's getting reduced. Okay? And that requires 2 electrons. Okay? So 1 electron to get it from 1 to 0, and another electron to get it from 0 to -1. Okay. That's that. So, we can now start balancing. We have an oxygen here, but we have no oxygen on this side, so we will add water. We now have 2 protons here. So what I will do is I will do this. 2 protons here. Another thing is on this side we don't have any oxygen, whereas on this side we have 3 oxygens. So I will do this. I will add 3 waters. Okay, and on this side I will end up with 6 protons. Okay, so 3 waters to account for this, and I have 6 hydrogens, so I will add 6 protons. Okay, perfect. Now this seems to be quite balanced to me. Let's balance the charges. On this side, 0 charge. On this side, I have 6. Then this -2 kicks in and it brings me down to 4. And, you know, how do I balance a -4? By adding -4 and turning it into 0. So this side and this side are kind of equal in balanced charges. What about this side? Well, I have 2 positives, okay? This one is -1, so it actually brings me down to 1. This one, okay, excluding the electron, we are now just 1, a positive 1 here. This side, I am just a -1. So how do I make it so I can match this? Well, I will easily just -2 from this. Okay, so 1 minus 2 gets me -1. And now both sides are kind of equally matched. I will try to match my electron number now by balancing. Okay, so this side has 4 electrons, this side has 2 electrons. So I would very easily just add 2 electrons here. I will become 2 OCl, 4 electrons, 4 protons, 2 of this and 2 of this. And now I will add my reaction. Okay. I will have sulfur plus 3 waters plus 2 OCl minus. I will cancel out the electrons, and I will have 4 protons on this side. We will say this equals to SO3 2 minus plus, again, 6 protons plus 2 Cl minus plus 2 kind of waters. Okay? So, we're not done yet. We need to cancel waters. So this water goes, this water goes. I'm only left with 1 water now. 4 protons here, 6 here. I'm left with, let's see, how many am I left with? 2 protons. Okay, and so let's continue this. So S plus 1 water, or water, plus 2 OCl minus equals SO3 2 minus plus 2 protons plus 2 Cl minus. Okay, now here comes the question. All right, what now? You know, like, what do you do? Well, we have protons in here still. We should aim to balance them out. How do I balance out these remaining protons? Well, I will add a hydroxide ion on this side. So I will add a hydroxide ion here, however many as needed to try and neutralize these protons. So I will add 2 OH minuses. Okay? Because, you know, if I have 1 H plus an OH minus, this will become what? 1 water. So I need 2 of them to make 2 waters. Okay? But remember, it's an equation, just like in math. So whatever you do to this side, you have to do to this side. So I will also add 2 OH minuses here. So let's see how this turns out. I have S plus 2OH minus plus water plus 2OCl minus equals to SO32 minus plus this guy and this guy will combine to make 2 waters for me and 2Cl minus. Now, one of these waters goes, okay, and I am just left now with S2OH minus plus 2OCl minus gets me SO32 minus plus 2Cl minus. This is my final balanced equation, okay? And, you know, let me kind of check. So we have S2OH, 2OCl minus, SO32 minus, 2Cl minus, and, sorry about that, I forgot. We canceled one water here, so there's one water remaining, and there we go. So this is the final balanced equation in basic solution. So you can see that the only thing that is different between a basic solution and an acidic solution is that I would only have to add hydroxide at the very end, like at this step. Of course, you can do this so much faster. I'm only doing it this slow because I'm teaching it, but you can complete this much faster. And there's, of course, no need for this at all, really. But, you know, that's going to finish it for balancing redox reactions.